Hi there. Welcome to the night before notes from Ashfield College. My name is Peter Jackson. I teach chemistry in Ashfield College. I'm going to tell you how to maximise your performance in the Leaving Cert chemistry exam. Let's talk first of all about the paper layout. Question 1 always deals with titration. Question 2 with organic practicals. Question 3 with the other practicals on the course. Question 4 are the short questions and of course short answers. Question 5 atomic structure, periodic table and bonding. Question 6 fuels and thermochemistry. Fuels being alkanes, alkenes and alkynes. Questions 7, 8 and 9, the order doesn't really matter. One of them is organic theory, what I call the flowchart and mechanisms. One of them is in Le Chatelier and equilibrium normally, and one of them is in environmental chemistry and acids and bases and pH. Question 10 is a mixture of questions. You have to do 2 out of 3, and the final question, question 11, you have a choice of 2 out of 4 parts. Each question is worth 50 marks. Timing in an exam is absolutely vital. You have to answer any 8 questions in the 3 hours allocated. You should read through the paper quickly. You can take up to 20 minutes to do this. As you do that, put 1 beside any questions you think you can answer fully, 3/4, a half, a quarter or 0 beside those that you don't think you can answer fully, and then you have 20 minutes to answer each question. Start by doing those with a 1 beside them and then go on to the 3/4 questions and so on. One of my favourite sayings is RTFQ, read the flipping question before you answer. Draw a vertical line at the end of each question on the paper. Some questions don't have a part number, so be aware of that. Think before you start to answer. As you finish each answer, put a tick after it on the paper. And don't rewrite the question, it wastes time. Don't write in prose, give bullet points. That's the easiest and quickest way to do it. In the exam, definitions are absolutely vital. They're worth about 10 to 15% in this exam. That's directly what does this word mean, explain this term, define this term. There are just over 100 definitions that have ever been asked. There's a link, I'll make a link available from the office if you phone it. Almost all questions have at least 1 definition, and the word is usually in italics to make it stand out. These get marks directly, usually 6 marks, sometimes 7, occasionally 8. But they also help you to understand the question, make learning the topic easier, and they're worth a lot more in reality, because when you understand the question, there's a much better chance that you will answer it correctly. So let's talk about question 1, the titration question. People are afraid of this because of the calculation, but the calculation is only a small part, maximum about 1/3 of the marks available. There are 3 parts to the question. The first part is how to use the apparatus properly. The second part is what indicator you use, what colour changes you see, and any special conditions such as with potassium permanganate you have to acidify it. And the calculation then is about 1/3 of the marks available. You can be asked to calculate the molarity of the solution, then its concentration in grams per litre, and finally its concentration in parts per million or milligrams per litre. They're exactly the same thing. Question 2 deals with organic experiments. Very often these days there's more than 1 topic covered in this question. For example, ethene and ethine are usually asked together. Sometimes a percentage yield calculation is involved. You should know how to do these. Question 3, the other experiments. What are the other experiments? Well, there's a test for anions and cations, the effect of concentration on reaction rate, the effect of temperature on reaction rate, and the production of oxygen from hydrogen peroxide using a manganese dioxide catalyst. Why are these in red? Well, these make up 3 of the questions, and therefore there's a very high probability that these will come up. You will almost certainly be asked to calculate either the instantaneous or the overall rate of the reaction. More often than not, the instantaneous rate. 2, 3 and 4 will usually involve drawing a graph. I'll talk about drawing graphs in a moment. The 6th experiment is relative molecular mass of a volatile liquid, recrystallization of benzoic acid and boiling and melting point determination, and the percentage of hypochlorite in bleach or swimming pool water, and finally the heat of reaction calculation, which will normally come up in question 6. Now, drawing graphs. People throw away marks hand over fist needlessly when drawing graphs. There are certain things you've got to make sure that you do in every graph. Use graph paper. There is graph paper in your answer booklet. Refer to the graph paper and the page it's on in your answer if you're drawing a graph. Label each axis with 3 things: what it is measuring, the scale, the numbers, and finally the units used. Make your graph large. It gives greater accuracy. Mark your points carefully. You will get sometimes 2 marks for marking your points, so make sure you mark them carefully, and then draw the line of best fit, either a curve or a straight line depending on the graph. If it's a straight line, draw a ruler. If it's a curve, draw a freehand curve. Do not join the points with straight lines, and do not extrapolate unless it is justified. It's not justified in the temperature versus rate of reaction experiment. Remember that one. Question 4, the short questions. It's the only question where you can get parts of it wrong and still get full marks. The questions come from anywhere on the course. It says answer 8 out of 11. Ignore that. Each answer gets 6 marks if correct, and then 2 bonus marks are given. That's 0.5% simply for doing the question. It's the only question where you can get parts wrong and score full marks. I've said that before. I'm saying it again to make it clear to you, so you do all parts of all questions. You will be given the marks from the best combination, even if it's only a guess. If it's a blank line, you get 0. If it happens to be right, you get the marks. Topics that appear regularly in this question include famous scientists and their contributions, definitions, electron, protons or neutrons in an atom or ion, the SPDF configuration of an atom or an ion. With an ion, it's only from the first 20 elements. Flame test colours come up quite a lot too. Conjugate acid base pairs, empirical formula from percentage composition, and mole calculations. Question 5 deals with atomic structure and periodic table. Topics which come up regularly include radioactivity, but it's often found also as half a question in questions 10 and 11. Mass spectrometer, again often found in questions 10 or 11. Ionization energies, line spectra, bonding and shapes of molecules, electronegativity, again this is often in questions 10 and 11. Question 6 deals with fuels and thermochemistry. There are invariably definitions here. You need to know about crude petroleum and fractional distillation and the fractions and what they do. For the first three fractions you have to know the number of carbon atoms in molecules in that fraction. Then other fuels such as hydrogen, octane number and factors that affect it and how you can improve it. Isomers, catalytic converters, what happens in them, and you don't need to balance the equations for catalytic converters. Heat of formation and heat of combustion equations, and Hess's law calculation is almost always found at the end of this question, and just occasionally the heat of reaction experiment. Question 7, and remember it can be 8 or 9, deals with organic theory. It's based mainly on the organic flowchart, and again you can apply to the front desk for a copy of this. The type of reaction, the reactants involved and the conditions required. It usually includes a reaction mechanism. One of the following always comes up: alkane, methane or ethane with chlorine, and it's a free radical substitution, and you need to know the proof of the mechanism. The second one that's most likely to come up is ethene with either chlorine, bromine or hydrogen chloride. This is an ionic addition reaction, and again you will need to know the proof of the mechanism. Occasionally you might get something about polymerization of ethene or propene. This is addition polymerization. Calculations are involved heavily in the question. Make sure you know how to do the following on your calculator. Change a number to a negative log and a negative log to a number. How to square root. Exponentials. Whenever you use a molecular mass in a calculation, always show on the page how you worked it out. For example, CaCO3 is 40 for the calcium, 12 for the carbon, and 16 times 3 for the 3 oxygens. That equals 100. If you got 99 by mistake and used it in a calculation, you would lose 1 mark, providing you had shown how you got it. If you didn't show how you got it and used the 99, you would lose 3 marks. So every time there's a calculation involving a molecular mass, that rule applies, so make sure you know it. Give your answers to either 2 significant figures or 2 places of decimals, whichever is the most accurate. For example, 2.64 not 2.6, or 0.0056 not 0.006. Incorrect rounding off will cost you 1 mark every time you do it. About 30 to 40% of the marks on the paper come from calculations. Practice, practice, practice your calculations is the mantra. Question 8 deals with environmental chemistry. Sometimes it can be question 7 or question 9, doesn't matter. This is water, acids and bases, and pH. Water treatment and sewage treatment are not as common as they used to be, but they can still be asked. Hardness of water and a calculation and ion exchange are frequent questions here. pH calculations, instead of being asked to work out the pH, you're most frequently nowadays given the pH and asked to work out the concentration. Practice doing these. With a bit of practice they become quite easy, and it's often a weak acid in the pH calculation. Question 9, again, sometimes question 7 or question 8. Definitions come up here very, very frequently. The effect of changing conditions on the reaction at equilibrium. Calculate the equilibrium constant, or given the equilibrium constant, work out the concentrations. That tends to be the more favoured type of question these days. You may have to use the quadratic equation, but check if you can square root both sides. If you can square root both sides, that stops you using the quadratic equation. And remember that in an equation such as N2 plus 3H2, it reversibly reacts to give us 2NH3, that the products are always minus, and the reactants are always minus, and the products are plus. So it's minus X, minus 3X because there's 3 hydrogens, and plus 2X because there's 2 ammonias. Always use the equation the way it is written in the paper, even if you're given the products and are asked to find out the concentration of reactants. Use the equation written in that direction. Questions 10 and 11 are mixed topics. In question 10 you have to do 2 out of 3 parts. In question 11 do 3 out of 4 parts. So these are well worth looking at to see if you can do them. Each part is worth 25 marks. It gives you extra choice. The topics here, frequent topics, include stoichiometry, or calculation is always one of these, radioactivity, electronegativity, energy levels, atomic structure. And 11D is always an options question. Atmospheric chemistry is the most common of these. Thank you for watching and good luck.